Myself, Jibin, Assistant Professor of Electrical and Electronics Engineering, Roguni College of Engineering and Technology. Today we are going to discuss about peak voltmeters. Passive circuits are not very frequently used these days for measurement of the peak value of ACR impulse voltages. The development of fully integrated operational amplifiers and other electronic circuits has made it possible to sample and hold such voltages and thus make measurement and therefore have replaced the conventional passive circuit. This is the structure of peak voltmeters. Suppose R2 and RD are not present and the supply voltage V, the voltage across the storage capacitor Cs will be equal to the peak value of the voltage across C2. Assuming voltage drop across the diode to be negligibly small. The voltage could be measured by an electrostatic voltmeter or other suitable voltmeters with very high input impedance. If the reverse current through the diode is very small and the discharge time constant of the storage capacitor very large, the storage capacitor will not discharge significantly for a long time and hence it will hold the voltage to its value for a long time. If now V is decreased and the voltage V2 is decreased proportionally, and since now the voltage across C2 is smaller than the voltage across CS, to which it is already charged, therefore the diode does not conduct and the voltage across CS does not follow the voltage across C2. Hence, a discharge resistor RD must be introduced into the circuit so that the voltage across CS follows the voltage across C2. From measurement point of view, it is desirable that the quantity to be measured should be indicated by the meter within a few seconds, and hence RD is so chosen that RDCS equal to 1 second. As a result of this, the following errors are introduced. With the connection of RD, the voltage across CS will decrease continuously even when the input voltage is kept constant. Also, it will discharge a capacitor C2 and the mean potential of V2 will gain a negative DC component. Hence, a leakage resistor R2 must be inserted in parallel with C2 to equalize these unipolar discharge currents. The cable capacitance comes parallel with the capacitance C2, which is usually changed in steps if the voltage to be measured is changed. A change of the length of the cable would thus also require recalibration of the system. The sheath of the coaxial cable picks up the electrostatic field and thus prevents the penetration of this field to the core of the conductor. Thank you.